Okay, I'm Andrew Willis. This is Project 4, Problem 1. Um, Here I have start from the top, the uh, custom flip flop that we made. Um, and everything works fine. It latches to the value, and it changes on the edge pulses. Um, I believe I just did the test cases there. Let's move on. Oh, here's the decoder. It works fine. Decodes values from 3 to 8. Um, okay, now for the 4-bit register. Let's see. We'll enable the pre-in, cycle out a couple times. Okay, um, we will select, we'll do the word select, and then we will put in 1100. And when we cycle the right, 1100. And I did the cycle, so that's the read. That's perfect. Now we'll do word select to 0, and we'll change this to the boom. And you see there's no output, so that's that. That's that one. Now we select. We'll do word select in, and we'll pulse the clock, and see we're back to where we are on that falling edge. And then we'll write 101. Oh, apologies, 1010. And we'll write. We'll see it's read and writ perfectly. So that one's good. Um, and then we combine all of that together for the 4-bit register here. I'll cycle pre-in and out a little bit. And now we'll do with the word select. I'll write raw for that. Now, with word select 1, we want to put in 1 1 1 1 0 0 0. See, it gets right there. I that was the read and the write. Perfect. And then now we will, with the word not selected, we'll see it does nothing. Leave it on a clock pulse. There we go. And then when word select is 1, you see it still outputs what it needed to. And then we want to write 0 1 0 1 0. And there's our write and our read. And it's good. That's all the cases there. And let me go grab the file for the 8x8. Okay, so here's the 8x8 memory module. It's its own file because it was lagging everything else so drastically. So I'm going to go ahead and do the test cases first, and then I'll explain kind of how it works as we go. So I'm going to cycle pre in and out a few times. Turn this yes, just to refresh everything. We'll leave it enabled so everything works. For the first case, we're trying to input, so I'll enable chip select. We'll leave the reading at 0, and we'll cycle that for the falling edge to read it. We're now on the 0th register. I selected from this mux here, and it wants us to write a 1 to that. So I'll go ahead and enable it and disable it to activate that falling edge trigger. We'll do it a second time because sometimes that first initial one has caused me problems. All right, and then we'll move on to that second register. We'll go here, and it wants this, so we'll go ahead and read that in. And then now for the third register here, wants that here, and we'll read that in. And then for the fourth register, we'll read that in. And now for register 5, we'll read that in. And then for register 6, read that in. For register 7, we'll read this in. And then for register 8, We'll read this in. Okay, now we'll go back to that. Go back to that first register. Here. Disable all the inputs. And now we'll go ahead and go to, this is the part I always mess up on, is moving to the reading. Chip select 1 and RD set to 1. Shouldn't make any edits because it should be falling edge triggered. So go ahead and re-enable chip select and read. And when we go here, boom. And then boom. And then boom. And then oh, boom. Boom. Where did it? Boom, there. Boom, and then boom. Okay. I think that's all of them. Oh, man. So many. And then that's a successful read-write. We have the pre and out here. This enables everything, how it's been for the last ages. Our input chain here, this selects the registers. This uses the 3 to 8 decoder that I made. And these are all the 8-bit registers that are simplified. This is the logical operations to make sure that chip select and read don't ever conflict. And we have the tri-state buffers here along those with giant OR gates to make sure that everything happens nicely. I originally had it so I had AND gates on all the outputs, and it just was even more of a mess than this. But yeah, this is the file. It's very, very laggy. But yeah, cool.